Alright, so this lesson is titled Warming Up, and the standards that it's going to cover are 8.4.2. Students will investigate and describe Earth's structure, systems, and processes. And 8.4.3, students will investigate and describe energy in Earth's systems. And so this is going to be a follow-up on last week's atmospheric reentry capsule lesson, where students learned a little bit about the atmosphere and the different densities in the atmosphere as you go away from Earth. And we're going to specifically focus today on the idea of the greenhouse effect. And so the first thing I'm going to have students do is the actual hands-on activity. And for this they're going to need a plastic container, something like this, that can, when it's set down, can cover up a thermometer so that the air inside of the container is not going to be able to escape. And they're also going to need, obviously, to be able to read that thermometer. And they'll also need another thermometer that's going to be sitting next to this container. And basically what they're doing here is setting up a mini greenhouse. And so as the gases, the air inside of this container warm up, they have nowhere to escape to, because the heat cannot escape through the plastic, or at least not a lot of it. And so we should see a much warmer temperature inside of this container as compared to the thermometer that's outside of the container. Now you can have, I'd like to have students work in groups of 2 or 3 on this, and it's best to do this out on a nice sunny day, and where they're actually going to be using the actual sun's energy to measure the temperature. And they need to set these thermometers out and be careful not to shade the outside thermometer with the capsule itself, so that you're not getting one thermometer in the shade and one in the sun. They need to let these sit one inside and one outside for maybe about 3 minutes or so to let the temperatures kind of come up to the outside temperature on the thermometers. And then they should take data every 2 minutes for maybe 10, or if you have time, 20 minutes, comparing the inside temperature to the outside temperature. Now after they've done that, they'll have some data, and then we'll move on to a discussion about this so-called greenhouse effect. And really, the easiest way to start is by talking about what happens in an actual greenhouse, like the small greenhouse they set up here. And what happens is, as energy radiates from the sun, it's actually traveling in the form of visible light, a lot of it. And that visible light is in the form of shortwave radiation, and so it can pass through glass or plastic. It's kind of like sitting in your car on a sunny day. Even if it's cold outside, as that shortwave radiation passes through the glass and items inside of the car or inside of the greenhouse absorb that heat, then those items re-radiate the heat in the form of longer wave infrared radiation. And that infrared radiation cannot escape through the glass. And so over time you get energy coming in, shortwave radiation coming in, warming up the air and the objects, and then the infrared long-wave radiation not being able to escape, and so it just gets hotter and hotter and hotter inside of the greenhouse until you open a door or inside your car, unless you roll down the window. So that's the way that it works when we're talking about glass, because it's actually not allowing the air to escape. And so as the air gets hotter, that hot air has nowhere to go. Now it's different when we talk about the greenhouse effect and the atmosphere. In the atmosphere, there's these certain kinds of gases called greenhouse gases, and the most familiar ones would be like carbon dioxide, methane, and water vapor. And what these gases do is, as the shortwave radiation comes from the sun, they allow that shortwave radiation to pass through, especially carbon dioxide and methane. And so that shortwave radiation passes through to the Earth's surface, where it's absorbed by the surface of the Earth and items on the surface of the Earth. Now, as those items heat up, they begin to re-radiate that heat, or that energy, in the form of longer wave infrared radiation, just like what happens in a greenhouse. Now the difference is, as that infrared radiation heads back up into space, a lot of it can escape. All right? There's not a glass bubble around the Earth, obviously. So it's a dynamic system where it's interacting with the space beyond itself. And so what happens is, some of that energy, though, some of that infrared radiation gets absorbed by those greenhouse gases, by the carbon dioxide and by the methane and by the water vapor. And then as those greenhouse gases absorb that energy, they radiate it back downwards towards the Earth. And so it's kind of, it's less like an actual greenhouse with glass, because there is absorption and re-radiation going both ways, and there is some heat escaping. But the take-home point of this lesson is going to be to help students understand that as the amount of greenhouse gas increases in the atmosphere, specifically carbon dioxide, because that is the greenhouse gas that humans are adding to the atmosphere at a very rapid rate, as that CO2 increases, the temperature of the Earth itself will increase, because there's more carbon dioxide molecules in the atmosphere, so there's more molecules absorbing more of that radiant heat as it's headed back to space, and less of that heat actually escaping the Earth's system. So obviously, in order to maintain a constant temperature at the Earth, an equal amount of energy would have to be coming into the Earth and leaving the Earth. And as the greenhouse gases grow, the amount of energy coming into the Earth system actually becomes a little bit greater than the energy leaving the Earth system. And so we see a general warming trend. And I have several graphs on the PowerPoint that show how CO2 levels have increased over the last 1,000 years, that show especially in the last 200 years there's been a very large spike in carbon dioxide emissions, in carbon dioxide in the atmosphere in general, and how the temperature has changed over the last 120 years. How there's a definite linear trend, straight up trend, I mean, and almost an exponential as we get into the last several decades, but there's been a very clear trend upwards in temperature that correlates to that carbon dioxide increase. And so it's going to be important to help students understand that the activities that they participate in, driving their cars, running their air conditioners, anything that requires the burning of fossil fuels releases carbon dioxide into the atmosphere, and that release of carbon dioxide has a direct effect on the Earth's climate, because carbon dioxide is that greenhouse gas that's going to trap heat, right, and re-radiate it back to the Earth. So that's the basic gist of the lesson, starting with the idea of an actual greenhouse and how that works, comparing that to the atmosphere, and then thinking about how what's happening in the atmosphere is related to daily activities that students are participating in. And so really good follow-ups to this lesson to continue to have kids think about how they impact the climate would be to have them do a carbon footprint analysis. And this can be difficult for upper elementary and middle school students because they don't always have a very good concept of how many miles their parents might drive or how much their heating bill is. But I think if you can help them, or maybe you could even just go through and do, as a teacher, you could do your carbon footprint analysis in front of the whole class, together with the class. And a lot of those carbon footprint calculators online will show you how many Earths it would actually take to sustain the human population if everyone lived the way you lived. And a lot of them you can even compare individuals in other countries and how they live and how many Earths it would take to sustain them. So it's a really interesting way to continue to think about personal responsibility for climate change. And so I think that'd be really the best way to extend this lesson. Another way would be, an extension of that itself would be to have students create informational posters about climate change and about what maybe their school or their town could do to help to curb it. Because let's face it, in the end, it's going to come down to individual efforts. No matter how much we want to blame someone else, no matter how much we want to just say that the government needs to crack down on this or that, in the end, the only the only thing that you yourself have power over is the change of your own lifestyle. And so, like Gandhi said, you must be the change you wish to see in the world. And so I think that's what we really want to instill in our students with this lesson and thinking about global climate change, thinking beyond themselves and how they themselves as an individual impact the larger climate. So it's kind of it's a big concept lesson that starts with a very simple activity. And I think we can have a really good conversation about climate change and about carbon dioxide production, and hopefully have a little bit of fun along the way. So that's it for this one, and we'll see you next time.